Hey guys, to figure out if I can simplify a fraction, all I'm really asking myself is there any number I can count by to get to both the numerator and the denominator? So I'm thinking to myself, what number can I count by to get to 6 and to 8? Well, I know that they are both even numbers, which means they're both divisible by 2. And I know I can count to 6 by going by 2, so I go 2, 4, 6. And then I know I can get to the denominator, which is 8, by counting by 2's as well. 2, 4, 6, 8. Which means that both of these are divisible by 2. So since they're both divisible by 2, we're going to reduce down. 6 divided by 2 leaves me with 3. 8 divided by 2 is 4. And again, you have to make sure that you divide both the numerator and the denominator by the same number. Now I'm left with 3/4. So now I'm asking myself, is this fraction in simplest form? Are there any numbers I can count by to get to both the numerator and the denominator? Well, the only number I can count by to get to 3 and 4 is 1, which means that this fraction is in simplest form. Let's look at another one. 21 over 24. Well, I know that I can get to 21 by counting by 3's. So I know the top is divisible, the numerator is divisible by 3. Let's count to 24 and see if I can get there counting by 3's. 3, 6, 9, 12, 15, 18, 21, 24. So I know that I can get to both numbers by counting by 3's, which means they're both divisible by 3, so I can reduce this down. 21 divided by 3 is 7, and 24 divided by 3 is 8. Now I'm thinking to myself, is there any number I can count by and to get to 7 and 8? Well, I know I can count by 1, and I also know that 7 is a prime number, meaning the only factors that go into 7 are 1 and 7. And prime numbers normally are in simplest form, so I'm finished here. This fraction is totally simplified. Let's look at a bigger one, 48 over 64. Now, since these numbers are big, if you know your multiplication tables really well, these problems are easy. But if you don't, you can always ask yourself, can I count by 2's or can I count by 3's? And the easiest way to know if you can count by 2's is, are both numbers even? If both numbers are even, then you can definitely count by 2's and simplify it down. These are both even numbers, so let's go ahead and just divide these down by 2. 48 divided by 2 is 24, and 64 divided by 2 is 32. Now, this is not the most simplified form, because both of these numbers can still be reduced down. So I'm going to rewrite my fraction down here, and I'm going to keep going, and I'm going to keep dividing by 2 throughout, since they're still both even numbers. 24 divided by 2 is 12, and 32 divided by 2 is 16. Yep, I can keep going here, so let me go ahead and divide by 2 again. 12 divided by 2 is going to leave me with 6, and 16 divided by 2 is going to leave me with 8. Now, believe it or not, these numbers are still not in simplest form, so I'm going to divide by 2 one last time. 6 divided by 2 is 3, and 8 divided by 2 is 4. Now I'm asking myself, is there any number I can count to get to both the numerator and the denominator? Well, I can count by 1's to get to 3, and I can count by 1's to get to 4, but that's it. So this is the most simplified form. Let's look at one last one, 17/20. So again, I'm asking myself, is there any number I can count by to get to both 17 and 20? Well, I know that 17 is an odd number and 20 is an even number, so 2 will not work in this scenario. So I'm thinking to myself, 1 is the only number I can count by to get to both 17 and 20, which means that this fraction is actually already in its simplest form. And sometimes that's going to happen. Now, a big key that you can look for is this numerator which is 17, is already a prime number. And remember, a prime number means that its only factors are 1 and itself, which is 17. And prime numbers are normally already in simplest form. So that's a way that you can think about it. All right, guys, that's going to be it for me today. Let's practice.